Let us connect CDF with sample outcomes. So the first step in calculation of CDF is what is the to see what is the random experiment. So the random experiment we will take here is tossing two fair coins. So before solving CDF problems, you should first see what is the random experiment. So we will take one example so that you will get one flow to the how to come to the CDF from the random experiment. So let us take random experiment as tossing two fair coins. So this is first step. So in the problem you have to see what is the random experiment. After that you have to compute the sample space. So sample space includes sample outcomes. That means what are the outputs of the random experiment. Those outcomes come in the sample space or in the sample space set. So if you toss two fair coins, then you will get either tail tail, head head, tail head, head or head and tail. That means you will get four outcomes. This is second step. After that, third step is you have to assign random variable. That also will be given in the problem. So this is the random variable is like that, whatever their condition is. So here we are taking the random variable as counting the number of heads in the sample outcome. So what is random variable? Random variable converts these sample outcomes. So there are four sample outcomes. These are converted to the real number by the random variable. So for that you will need one condition. So that condition here given is counting number of heads in the sample outcome. So count the number of heads in the sample outcome. So here heads are 0, so 0. Then here 2, so 2. Here head is 1, so 1. Here 1. So this is third step. After that you have to see uh, different values of random variable. So the different values of random variable are 0, 2 and 1. 1 is repeating, so don't take it. So x takes 3 values only, not 4, because 1 is repeating. So x takes 0, 1, 2. So after that you have to assign these values some alphabet as per this alphabet. So if you have taken y, then you have to take y naught. Here x we have taken, so first value we were assigning as x naught. So you x naught, then 1 is x1, 2 is x2. So these values you have to arrange in ascending order. So you cannot take 2 first. So 0, 1, 2. So 0 x naught, then 1 x1, then 2 x2. Likewise, ascending is important. So randomly you will get here 0, 2, 1, 1. After that you have to assign the values with ascending order. So 0 for x naught, then 1 x1, then 2 x2. So this is third step. So first step is random experiment. Second step is what are the outcomes of the random experiment. Third step is seeing in the problem what is the random variable condition. Accordingly give the values, real values to these sample outcomes. Then then arrange these random random variable values in ascending order and assign some alphabets to those random variables. And here condition is that any random variable value which is repeating, you have to skip that. You don't have to assign the random variable alphabet for that random variable value. So fourth step. After that you have to find the probabilities for these random variables. Probabilities for random variables. Random variable values, sorry. Probability for random variable values. This is random variable which is 1 only here, and random variable values are 3, x0, x1, x2. So while finding the probability of random variable value, you have to again take this set here. So tt, hh, th, ht. So tt corresponds to x0, 0. Then hh corresponds to x2, th corresponds to x1, ht corresponds to x1. So probability x equal to x0. So here you have to see x naught comes for one time, and how many outcomes are there? 4. So it is 1 by 4. So if you calculate the probability from here, you will get 1 by 3. Okay, so you will get for finding the probability, you don't have to see this. You have to take this set here and then find the probability. After that, probability x equal to x1, x1 coming for 2 times, so 2 by 4. Probability x equal to x2, x2 coming for 1 time, so 1 by 4. So this is 4th step. 5th step is CDF. You will come to the CDF. So CDF notation is f, capital F, random variable capital X, and its value small x, fx x. So it will be probabilities 3. You will get 3 CDF values. At 3 you will get CDF transition or CDF change or constant value at 3 points, that is x0, x1, x2. So first point is probability x is less than or equal to x0. That is first CDF value, fx x0. So probability x is less than or equal to x0 is, before it there is nothing, so x equal to x0, probability is 1 by 4, so value is 1 by 4. Then probability x is less than or equal to x1 at this point, that is fx x1. So it includes 2 by 4 plus 1 by 4, that is 3 by 4. Last is probability x is less than or equal to x2, so that is equal to 1 by 4 plus 2 by 4 plus 1 by 4, that is 1. So lastly you should get 1. CDF last value is 1. So this is the flow or a sequence for finding the CDF value. This is important because if you understand this sequence, then you can solve any problem. So mostly the confusion creates here. So here we may assign 4 values, x0, x1, x2, x3. Again you have to arrange it in ascending order, and for finding the probability you have to take this set here. For finding probability of these random variables, don't see here. So here we will make mistake. For finding this probability we see this set. For finding the probability, you have to take this set and you have to skip the repeated value and arrange it in ascending order. So I feel it is important because there are very lengthy problems on CDF, but if you understand with a small problem what is the sequence, then that you can apply for the lengthy problems.